All right, so let's first start with length. All right, so this is from Friday. I'm going to go ahead and I'm going to flip my page. I'm going to start with today's date. I'm hoping that your diagram is right in between Friday and today. So it's in between the 2 days is what I'm hoping if you were here Friday. So today is the 9th. And we're talking about 3.7 continued. And this is the metric system. All right, so let's talk about length. I'm not going through every single like decameter and hectometer because those we don't use all that often. I'm going to kind of talk a little bit about the ones that are most commonly used. Well, first of all, meter, that's an M for meter. This is the base unit. It's the suffix to all of these. All right, when we talk about a meter, this is about the distance from a doorknob to the floor. It's a little bit bigger than a yard. Bit bigger than a yard. How many feet are in a yard? Romano? How many feet are in a yard? Aaron? 3 feet in a yard. So 3 feet is like the width of the door. Right? That's a typical width of a door is 3 feet wide. All right, so a meter is a little bit bigger than that. All right, a centimeter. All right, a centimeter, if this is our ruler, right here, inches are at the bottom, centimeters are right here. So you can kind of see the difference between a centimeter, which is this distance right here, and an inch, which is this distance right here. All right, so a centimeter is about the width of a thumbnail. It's about the width of a thumbnail, depending on how wide your thumbnail is. Mine's probably a little bit wider than that. Mine's probably more like my finger, my pointer finger. All right, it's about a third of an inch. All right, when we talk about a kilometer or a kilometer, both of them are said. That's about a half a mile, a little more than a half a mile. So I feel like it's important for you guys to attach these metric system measurements to our United States measurements because I think that they're most common to you and that you can, if you can be like, oh, a half a mile, I kind of know how far that is, right? The other one is a millimeter. That's about the thickness of a dime. So a millimeter is about the thickness of a dime. All right, and if you look again at this ruler, a millimeter is just this little tiny distance between this little tiny increment here. That's a millimeter. And there are 10 millimeters in a centimeter. All right, so let's look at capacity. Our capacity is the same thing as volume. There are two that we typically, liters is the base unit. If the big ones that we usually use are milliliter. Yep, milliliter. That's M, capital L. I didn't do the abbreviations on the last one, but we will do those. All right, a milliliter is 5 drops of water. So if you're ever taking like amoxicillin or you're taking some liquid medicine because you have some sort of, a cold or a viral bacterial infection, you get the little tiny cup out, you know what I mean? You pour it in a little tiny cup. Those little tiny cups are in milliliters. You're probably taking either 5 milliliters or 10 milliliters of something. All right, so 1 milliliter is about 5 drops of water. All right, when we talk about a liter, that's capital L. All right, that's a little bit more than a quart of milk. It's a bit more than a quart of milk. So when you guys go get pop at the store and you're having a party, your mom and dad get those big bottles of pop, those are 2 liters. All right, those are 2 liters. This is probably about a liter. This is about, because if you think about that 2 liter of pop, this is probably maybe half of that, maybe a little less than half of that. Okay? If I take a look at this is done in weight. This is about 500 grams, which is about 1 1.25 pounds. All right, so this is done in volume. If this was in weight, if I filled this up with water or something, how many liters do you think this might be? If this is about 1 liter, and you know what a 2 liter looks like, how much would you think this might fill up? How many liters? And it's approximate, because I'm approximating too, because I don't know. I'm doing the same thing you are. I'm like, okay, how much of that 2 liter do I think I'm going to pour in here? What do you guys think? Layla? How many of you guys agree that 1.5 liters maybe? Yeah, not quite the 2 liter, but probably more than this. Do you guys agree with that? Yeah, so that's just I want you guys having a magnitude of what this could be. All right, when we talk about mass, and that, I equate that to weight. We talk about mass. The base unit for mass is grams. That's the base unit. All right, milligrams. That's lowercase m, lowercase g, milligrams. That is about a speck of sawdust. It's about the weight of a speck of sawdust. If you look at like if you look at medicine, I just have Motrin here. All right, so one of these long tablets, 500 milligrams. That is the weight of that. Totally just slipped right out of my hand. So this is about 500 milligrams. All right, you wouldn't think that, would you? Because it's not that heavy, right? It's very light, which is why a milligram is the weight of a speck of sawdust. So like the pencil shavings over there, if you take one of those pencil shavings, that's a milligram. All right, so that's the size of it. All right, we also talk about grams. That's just GM for gram, or just G. I always do GM. That's just G. All right, this is about the weight of a paper clip. All right, so that's what would be measured in grams. So 1 gram is about the weight of a paper clip. And then when we talk about kilograms, that's kg. That's about that's about half the mass of a textbook. Half the weight or mass of a textbook. Like this size textbook. So this is probably 2 kilograms. What's your little book in Mrs. Lipka's class? English, that your little English book? That's probably a kilogram. Right? Is it smaller? All right, so that's probably a kilogram. Your Spanish book is probably a kilogram because it's thick. It's much thinner than this book. Okay, so you guys have kind of an idea of the sizes of these things. Okay, so let me ask you something. If I was to put you on a scale, and I would never put you guys on a scale, but if I was to put you on a scale, what would be the most appropriate unit of weight measurement? Would you be measuring yourself in milligrams? Would you measure yourself in grams? Not that you couldn't measure yourself in these things, but what is the most appropriate unit of measure? That would be like, would you measure yourself in ounces or would you measure yourself in pounds? Like, what is most appropriate in our metrics? Michaela, what do you think? Well, in our metric system. I do agree with pounds, but if we're looking at metrics, so we have milligrams, we have grams, we have kilograms. What do you think is the most appropriate unit then? Mia? How many of you guys, sit up please, Dominic. How many of you guys think grams would be the most appropriate? All right, if you don't think grams, what do you think would be the most appropriate? Kira? I think probably kilograms, right? Because this book is probably 2 kilograms. Sit up please. This book is 2 kilograms. So don't you think that it's probably most appropriate if you measured yours in kilograms too? Right? How many of you guys would agree with that? Right, you're probably not going to measure yourself in ounces, would you? All right, so think of kilograms like pounds. All right, so I'm going to talk about appropriate units of measure. That's not to say that you can't measure yourself in the other ones. It's just what's the most appropriate. So if I said to you your weight, we would probably say kilograms. How about the width of your desk? Right, we have meters, centimeters, millimeters, kilometers. What do you think is probably the most appropriate unit measured for the width of your desk? Mateo? Excuse me? How many of you guys agree that a meter is probably the most appropriate unit measure? How many meters do you think it is? Anybody? How many meters do you think the width of your desk is? Go back and look at what 1 meter is approximately. Jack? Maybe 3/4 of a meter? How many of you guys agree that 3/4 of a meter is probably the width of your desk? Because it's the length, it's the height between your doorknob and the floor. All right, do you think that's the most appropriate and the most accurate would be meters? Is there another one, millimeters, centimeters, meters, kilometers? Those are most common. Are any of those probably a little bit more appropriate that you can get it more accurate? Alex? Yeah, I would probably say centimeters. You can do meters, but it probably wouldn't be quite as appropriate because if I had a meter stick, you're not sure, you would be estimating maybe 3/4. But with centimeters, we probably can get a lot more accurate because they're smaller. So I would say centimeters. Can you guys kind of see how that works, like the most appropriate? Okay. All right. The biggest thing that I want to do is I want to, let me ask you this. So choose a reasonable measure estimate. All right, so if I said to you the capacity, remember capacity is volume, the capacity of a juice box, do you think it's 200 milliliters or 200 liters? Which one do you think is most reasonable? A juice box, do you think it's 200 milliliters or 200 liters? Christiana? Yeah, I think 200 milliliters. 200 liters. What do you think is close to 200 liters or might be close to 200 liters? Jack? Yeah, maybe two 12 packs of it. That might be, right? Your bathtub, that might be 200 milliliters, right? That would mean that you would have 100 2 liters poured into something is kind of the magnitude. All right, how about the length of your pencil? Is that going to be 15 centimeters or 15 meters? Which one do you think is more reasonable? Like a brand new pencil. Do you think that the more reasonable is 15 centimeters or 15 meters? Vincent? Yeah, I would say 15 centimeters. 15 meters. That's like really far, right? Remember, a meter is a little more than 3 feet. All right, so I want you to understand the magnitude of these sizes. Are you cool with just these 2 exercises that I just did? Okay, so now let's talk about converting between metrics. So all of you, I'm not going to go through, I like that I already had you guys for homework put this into your notebook. All right, so you have something to refer to. I need for you guys to remember the base units, the full names, and the abbreviations, and the order of measures. So those are the most important things right now. So I'm going to go ahead and just put I'm going to use meters right now as my base unit. And I'm going to quickly write down my diagram. So if I have meters, that goes right in the middle. What's one smaller than a meter? What's one smaller, just down from a meter? Pierre? Look at your diagram. Don't try and do it from memory. Make sure it's right. Frankie? It's a decimeter. D-E-C-I-M-E-T-E-R. What is the abbreviation for a decimeter, Frankie? DM. So decimeter, that's DM. What's next lower than a decimeter? Pierre? What's the one you already said? So centimeter is one lower than that. That's CM. So deci means 10. How many of you guys knew that? Deci means 10. Centi means 100. What does milli mean? Alex? 1,000. That's how far those are away from your meter. That's one way to remember this. So millimeter is the next one, mm. Now, if I'm going from a meter to a decimeter, I'm going from a bigger unit of measure to a smaller, which means I'm going to have more of them. So if the distance from the doorknob to the floor is 1 meter, how many centimeters would that be? Remember, in between each unit of measure is 10. You either are multiplying by 10 or you're dividing by 10. That's one of the diagrams that you had there. So a way to remember this is I'm going from a bigger unit of measure to a smaller. Am I going to have more of those smaller or less of those smaller? Layla? I'm going to have more of them. So I would multiply my number of meters by 10. So when I'm going from a bigger unit of measure to a smaller, so bigger unit of measure to smaller, we multiply by tens. That's going in that direction. We're going to multiply by 10, 100,000. All right, so in between each of these, going from a bigger to a smaller is multiplying by 10. So if I went from meters all the way over to millimeters, I would multiply by 1,000 because it's 3 jumps away from my meters. All right, what's one bigger than a meter? If you don't remember, go back to your diagram. What's one bigger than a meter? Jack? Yep, that's decameter. D-E-K-A-M-E-T-E-R. And that is D-A-M is the abbreviation. If I'm going from a meter to a decameter, I'm going from a bigger unit, a smaller unit of measure to a bigger. That's when we divide by 10. All right, so let me write that down. Let me get a different color. So when I go from a smaller unit of measure to a bigger, which is going in that direction, we are going to divide by 10, 100, or 1,000. What is one bigger than a decameter? Jack? That's a hectometer. And that's HM. Right? And we divide by 10. Don't forget the arrow to show what direction you're going, please. I divide by 10 to get from a hecto to a deca. I'm sorry, a deca to hecto. And the last is a kilometer. And that's km. And again, to go from a hecto to a kilometer to a kilo, we also divide by 10. So let's use this to go between units of measure. So the vast majority of tonight's homework is you converting from one unit of measure to another. This stuff is just a synopsis of what you already have in your notes. All right, so let me show you exactly what I'm looking for you to do to show this conversion. I'm not looking for you to do any long multiplication or long division. We're going to use moving our decimal. All right, so what I want to do is I want you to convert. We're going to convert between units. Is that rain? Oh, it's pouring. Okay, so what I would always do is consult with your diagram. Don't guess. Consult with your diagram. The more you do of these, the better, the easier it's going to be. So let's say I have 4.35 liters, and I want to go to milliliters. Liter is always a capital L. So that capital L, milliliter, small m, capital L. All right, so what I want you guys to do is I'm going to start with rewriting my given. If I go back to my diagram, if I'm starting with my base unit, I'm starting with liters, even though this is an M, this is where liters would go. I'm starting with liters. I need to go to milliliters. How many jumps is it away from liters to milliliters? Ladies, how many jumps is it away from liters to milliliters? Frankie? It's 3 jumps. So, it's 3 jumps from liters to milliliters. So what that means is, so if I did this, liter, deciliter, or deciliter, centiliter, milliliter, it's 3 jumps. So that means that we have 3 zeros. So the number of jumps is the number of zeros. All right, so what I know that I'm going to be doing is I know that I'm either going to be multiplying my 4.35 by 1,000 or dividing. If I'm going from a bigger unit of measure to a smaller, am I multiplying or am I dividing? So I'm going from a bigger to a smaller. Am I multiplying by 1,000 or dividing by 1,000? Aaron? Yeah, we're going to be multiplying by that 1,000. So I'm going to go ahead and put my multiplication in there. If I multiply by 1,000, what happens to my decimal? If I multiply by 1,000, what happens to my decimal? I need to move it. Am I moving it left or am I moving it right? If I'm multiplying by 1,000. Remember, multiplying by 1,000 means I'm making my number bigger. So am I going to move my decimal to my right or am I going to move my decimal to my left? Romano? So I'm going to move it to the right because I'm making it bigger. There are 3 jumps, so it's 3 decimal places. So 3 jumps means move decimal 3 places. So I'm just going to fill in a 0 where it's missing. All right, so 4.35 liters is equal to 4,350 milliliters. All right, so this is all that I should see. I should see multiplying or dividing by whatever the number is. If it's helpful for you to write this down to figure out the number of jumps, that's fine with me. But I need to see this. I need to see what you're multiplying or dividing your number by. I need to see the movement of the decimal, and then I need to see the final answer. Let's do another one. All right, so let's say I want to, I have 914 centimeters, and I want to know what that is in kilometers. All right, so you've got to figure out your number of jumps. If you want to write it down and do it, that's fine. If you want to go to your diagram, let's figure it out. I'm going from centimeters to kilometers. How many jumps is it from centimeters to kilometers? Mateo, how many jumps is that? So, yep, 1, 2, wait, say that again. 1, 2, 3, 4. Where's the 5th one? So I'm starting at centimeter. 1, I might be wrong. 1, 2, 3, 4, 5. You're right, 5. So there's 5 jumps. Thank you, Mateo. That's why I wanted to look at it. 5 jumps. So what that means is I have 914. I'm either going to multiply or divide it by 1 with 5 zeros on it. 1, 2, 3, 4, 5. So that's 100,000. All right, Mateo, I'm going from a smaller unit to a bigger. Am I dividing by that 100,000 or multiplying? I'm dividing. So this means we're dividing. All right, so I have my 914. Where's my decimal right now in my 914? Excuse me? Mateo, where is it? Someone help him out. Where is it? Kira? Yeah, it's right at the very end. So if you don't see one, it's at the end. So how many spaces am I moving my decimal in which direction? Alex, which way am I moving it and how many spaces? 5 to the left, because I'm dividing by something, which means I'm making my number smaller. All right, so 1, 2, 3, 4, 5. There's my new decimal place. I'm going to put zeros in where there's no digits. So 914 centimeters is 0.00914 kilometers. Are you guys cool with this? This is all the work that I should see. All right, use that diagram to figure out your number of jumps. Always talk about your number of jumps, because that translates to your number of zeros, and it translates to how many place values you're moving your decimal. Are you guys cool with this? You do not need to show me any long multiplication. So don't show me 914 times 100,000. Okay, just move the decimal. All right, you guys are good to go.